this is quite a good example to have a look at, not only because you'll be drawing a cumulative frequency polygon and histogram, and note that they've referred to it as an ogive here, but also you'll get to see and revise again the concept of grouped data. So the data has been broken up into groups, or another word that's often used is a class. And you can see that here, that they've actually referred to the class center. So this is an example of grouped data. Each group is often referred to as a class, and to generally do calculations for, say, mean, then we would use the class center. Now, we're going to be estimating the median and the upper quartile, and you're going to see that the graph gives us an actual nicer estimate for these values, especially when we've got group data. Now, I'll explain that a little bit more when you can actually see the graph. Just note that these classes go from 35 up to and everything, but not including the 45. But we've got to think about, an age of 44 and 10 months, or 44 and 11 months, etc. So anything still in the 44 year age bracket, but once we get to 45, then we need anyone who is actually 45, their results would be recorded here in this group. Class centres are between 35 and 45. The class centre is 40, 50, 60. I just noticed on the previous topic test some students had a little bit of difficulty with that. So please have another look at these and make sure you've got that sorted if you were one of those people that had trouble with it in the previous chapter. So these frequencies, we've got quite a big data set here. We've got 28 people in this group and 61 here, 65, 92 in this group and 74 in this age group. So we've got getting quite a large data group. In fact, we know that altogether 320 women were surveyed. So it says draw an ogive for this data. Now, before you ever draw an ogive, you'll draw a histogram. Then find the median, the third quartile, or Q3, the ninth decile. So now we'll be breaking our last column into tenths and looking for the ninth decile. And obviously the interquartile range, Q3 minus Q1. So at some stage we'll have to identify Q1. I suggest now that you pause the video and start your construction of your histogram and then your cumulative frequency ogive, and restart. Once you've done that, restart the video and have a look at the solution that I'm going to post, which is I'm actually taking from the textbook. Okay, as you can see now, I've taken the solution and inserted it here. You can see that the histogram was first constructed. Well, you might not be able to see that, but the histogram was constructed first. Now, the features that we'd expect about the histogram, half a column width has been left at the beginning. This is half column width. This would be the class centre, and remember that was 40. 40 was here in the centre, and 50 was in the centre. Now, what they've also done is actually put the limits on the edges of the columns. That's really going to help us to estimate the values from our construction lines. Now, let's just keep going. Ogive then is constructed by cutting across each column, across the top of each column to the right-hand corner. Notice that our columns are all getting taller. That is the unique feature of a cumulative frequency histogram. The columns continually rise. Our last column represents 100% of the scores. This is 100% of the scores, all laid out in order, smallest to biggest. Now, when we want the median, we want halfway. So we're going to use this value here, 320, and half of 320 would be at 160. So to find the score that occurs halfway through 320 scores, we construct a line from 160. And by the way, if you're still wondering where that 160 came from, it's 320 divided by 2. That's 160. So we come across until we hit the ogive. Now, look at where it is. It's only just inside that column. And we come down to read off an approximation of the age from our graph, or from this axis. We know that the middle was 70. However, our line, our cumulative frequency polygon line, has been able to give us a more accurate estimation. So although we're in the column where the class centre is age 70, we can see that we're dropping down only just inside that column. Knowing that that column starts at 65, an appropriate estimation for the median would be this 66. So that's what I was referring to previously when I said our ogive needs to be constructed accurately so that when we use it, we're getting a closer estimation to these statistical calculations, for example, median. Q1 I don't think was asked for, but if we were getting Q1, which we'll need to for the interquartile range, then we now want half of 160. So 160 divided by 2 is at 80. So from 80, dot across until you hit the ogive. Coming down, again, you see, well, we're a considerable distance across the column this time. So we're well past 50, knowing that the column finishes on 55, an appropriate estimation would be 53. I guess they might even take a 54. And likewise, Q3, we now want halfway between 160 and 320, which is up here at 240, coming across until we hit the ogive. Similar to the median, we're a good way across the column before we hit the ogive, coming down very, very close to 75. So an estimation for Q3, or your upper quartile, is this 74, because you're very close to 75. Now, D9, that's the 9th decile. Now, let's do just a bit of calculation to see why they started here. Why did they start there? So we've got a total of 320 results altogether. Breaking that into 10 even groups gives me 32 to a group. If I want the 9th decile, then I want 32 times 9. 2 9s are 18, 3 9s 27, and 1's 28. We want the 288th result. So you can see it's just over the 280. And we go across till we hit the ogive or the cumulative frequency polygon come down. Now, this was very close to the middle of the column. Remember, the middle score here is 80, and yes, they've estimated that the 9th decile would be there at 80. The only calculation you can't see from that is your answer to D, which is the interquartile range, which we can now read off. Q3 being 74, Q1 being 53. The interquartile range in ages is, 21. If you want more explanation about that, you can go to your textbook because, like I said, this example comes straight from your textbook. But for now, please complete your summary for this exercise and do exercise 10.05. Just note the example I'm going to do with you in class is also on the OneNote, and obviously you won't be doing that one.